Hey guys, welcome to the 15th tutorial in our Pandas course. Now we should be fairly familiar with a few techniques used to create Pandas data frames. We're going to work on fetching elements from them, either by row, column, or combination of the both to get a specific element. So we'll start by guessing data frame elements based on their columns. Then we'll do the same based on rows. And then we can take a look at slicing columns and rows to get specific pieces of data frames, and finally how to get them based on Boolean tests. Now, like with the series portion, we'll probably divide this into two sections. The first one here will just be focusing on guessing entire rows or columns or a single element. In the next one, we can focus more on slicing, Booleans, and a couple of other techniques. So let's head on over to the code now. Alright, last time we left off in section number 14, that was just creating data frames with dictionaries and series. I'm actually going to use one of these same data frames and modify it a little bit to demonstrate some of the techniques. So make sure again that you are running here and that you have your imports, and we can get started. Okay, so let's create a new cell. I'm just going to again copy and paste over one of these data frames. Okay, and modify it a little bit, so I'm actually just going to add another column to it. Let's put it right there. And this will help us to demonstrate some of the techniques. It would definitely help if you have at least 3 columns and 3 rows. So in this case, I have 3 columns and I think 4 rows. I'm just going to enter some different values here. We'll do like an 8 and then a 9 or something. Okay, cool. So this is what the data frame is going to look like for reference. And let's see. So we're probably missing like a comma or something here. Okay, yes, we are missing a curly bracket. Okay, there we go. Good stuff. Alright, don't worry about this. Warning sometimes comes up, not 100% sure what that's all about, but don't worry about it, so we can just rerun the cell. Okay, so your data frame might look a bit different depending on what values you're passing in. Doesn't really matter. Again, having like 3 columns and at least 3 rows would definitely help to demonstrate some of the concepts. Now I'm also going to print out just like a dotted line underneath. And the reason I'm doing this is because I want to print my data frame every single time, but then I also want to print out whatever technique I'm trying to demonstrate. And this will help us to kind of pick apart exactly which pieces of this data frame that we're fetching. Okay, cool. Now, the first thing that we might want to do is get items based on columns, okay? Or rather get an entire column of a data frame. That's actually super easy. All we need is the name of the data frame, in this case df, the square brackets, and then the column index label. So we have explicitly assigned labels, column 1, 2, and 3, so we have to use those when we're trying to fetch things. For example, this would be the first column, second column, third column, and so on and so forth. We can't just pass in the index of the column unless that is the column label. So if you don't explicitly assign them, the default labels are just 0, 1, and 2. So in that case, this is totally fine. But for us, we have to pass in the actual label here. So I'm just going to create a variable called first column. Okay, set it equal to this, and I'm just going to print out what it looks like. Okay, here we go. So you can see that it's arranged in a format that we've seen many times before. This is indeed a Pandas series. In fact, you can verify that just by printing out the type of our first column, like so. We can see that is a Pandas series. And this has just taken the first row's worth of data. So it's taken the labels, 1, 2, 3, and 4, and assigned them. It's taken the values, 1, 2, 3, and not a number. It's given us the type, it's given us the name, and everything that we might need. So this is the whole column's worth of data. Now, generally speaking, when we get an entire row or an entire column, that is going to give us a Pandas series. If we're getting a single element, it will just be whatever that type is, object, float, integer, etc. Depending on how we're slicing things, we might end up with a series or we might end up with a whole new data frame. Okay, so it's important to note what we're actually getting back. If you see something formatted like this, probably a data frame. If you see something formatted like this, especially with the name and data type, you're probably dealing with a series. All right. So the other thing that we can do is just create, or rather just get the data frame column based on a built-in property. Every time we assign specific labels to our data frame, for the columns at least, it creates properties or variables for us to fetch. For example, I can do the same thing here, getting the first column by doing df.col1. And this is because we've assigned again the label col1 to one of the columns. And so it creates a property or variables for us to fetch. Similarly, I can do col2 or col3. You can actually see them all pop up there. In my case, I'm again just going to stick with col1 for a reference, and you can see that's printing out the exact same data there, as it should. Now finally, when we're fetching a whole column's worth of data, we can also get things based on the get function. Just like with Pandas series, we can basically put in the label of what we're trying to fetch, as well as a default value for if that label doesn't exist. Now, for whatever reason, Pandas library only allows this function on columns, but not rows. So I can do something like first column is equal to dataframe.get, and I can pass in my label here. But I can't pass in a row label, for example, row 1. That's not going to get me the result that I want. Okay, so it's actually just going to return me none. Now it's nice it doesn't crash things, but it's still not going to get me what I want. For that, I can provide a default value. And then again, I can put in whatever I want. So I can do a single value of 0 if I really want. I can put in an entire series, which would probably make a bit more sense in our case. Okay, so I can do a series like this. But again, we fetch columns and not rows. So again, let's say col1, that works. If we try to get a column that doesn't exist, again, it's just going to return us the default value, whatever it might be. Okay, so that is most of what we need to know when we're trying to fetch columns. Now let's move on to rows. When we're fetching rows, there's two functions actually that we can use. One is called .lock, like this, and one is .ilock. And so .lock will get us a row based on its row label, so in this case row 1, 2, 3, or 4. And ilock will get a row based on its positional index, so in this case 0, 1, or 2, or 3. Okay? So we can use a combination of lock and ilocks with columns to fetch individual elements, but we'll cover that in just a minute here. Let's say I wanted my first row. I could do df.lock again, and again, location is going to take in an index label. So in this case, row 1 would be my very first row. If I wanted to print that out, I can do so. Okay. Note how this is kind of giving us a series again, but it's flipped the labels that were columns to now be row labels and then passed in the corresponding value. So for example, 1 was attached to column 1, so it created that, 4 to column 2, and 10 to column 3. Now the other technique would be using ilock, so we can do exactly the same thing, but ilock and then the index that we want. So in this case, it would just be a 0. Okay. We get the exact same result here. The big difference would be that if I know what my index labels are, perhaps this is the best way of doing things. If I don't know what the index labels are and I'm just getting a position, then this is kind of the way to go. So this is kind of cool. It's almost like performing a transpose operation in that we're just kind of putting the column labels as now the row labels of a series. And then we're of course assigning the correct values. So you can see that this is indeed a series and not a data frame. As I said earlier, we cannot actually use the get function on rows, but that's fine. There's a couple of ways we can get them anyway. Now, the other thing I wanted to go over, and actually this is the last thing, is fetching individual elements. There's a few ways we can do this, so let's just call this single elements. Okay, and there's really no way that is the best way necessarily. It really depends on the information that you have at hand. So, for example, if you know what the column label is, then you can do something like df and then the column label, and then you can get the location, so you can do .lock or .ilock from here. Okay. Alternatively, you can actually just use the .lock or ilock, but we'll demonstrate all of those techniques. So let's say I know what my column and my row labels are. So let's say I'm just trying to get the first element. I'm going to create a variable called first, and I'm going to apply column 1, because this will fetch me everything in my first column, just this stuff. And then I want I know what my row label is, so I'm going to pass in lock and then the row label. So in this case, row 1. Okay, if I want to just print out what that will look like, it should just give me my first element, 1.0. Indeed it does, so good stuff. So let's say I know what my column name is, but I don't know what my row name is. I know the index I want, again that's going to be index 0, but I don't know what the label is. For this, I can use again col1, and I can use ilock, and then 0. Okay, and that will give me again the column 1, and then the row index of 0. Okay, so alternatively, if I don't want to use this technique, I can just pass in, or I can just use the lock or ilock. So if I want, again, my first element, I can use df.lock. But this time I need to pass in first the row label, because this is assuming if I'm using lock, I know what the row label is, so row 1. And this is assuming I also know the column index, and that I would put second, so column 1. And the reason we do things in this order, row and then column here, is because the lock function expects its first argument to be the row label. Okay, so we couldn't then do column 1 and then row 1, that's not going to give us the results. Similarly, I guess I should demonstrate that. Similarly, we can get the items on index ilock 0, 0. So let's just copy and paste that. We're going to do ilock here. And then we're going to do the row index and then the column index, in this case 0 and 0. So that's great if you don't know any of the labels as well. But you're sure that it has at least one element at index 0, 0. Alright, so I think that is actually all we wanted to cover here, and we've got lots more coming up in the next section, so let's quickly summarize this and then we'll move on. So here we started by creating a data frame, just a few rows and a few columns for us to kind of demonstrate some of these techniques. We'll probably use the same one in the next section, so it definitely helps to be familiar with it. We learned some techniques to get columns, that's either by passing in the label like this, guessing the property that's created, or using the get function, which has a default value if nothing's found. We also learn how to get items based on rows using the lock and the ilock functions. Again, lock will take in a label, ilock the index, and then we'll learn how to get single elements using a combination of these techniques. Okay, so the next section will be focusing more so on slicing, Boolean tests, and then using these functions called head or tail, but more on that coming right up. So stay tuned, thanks for watching, and see you guys in the next one. Hello guys, welcome to the 16th tutorial in our Pandas course. Here we'll continue on with getting elements from data frames. Previously we took a look at just how to fetch columns and rows as well as single elements from data frames. Now we're going to focus more on slicing and getting elements based on booleans as well as just a couple other bits of functionality. So let's head on over to the code and get started. Alright, last time we left off in section number 15, again getting rows and columns. Now we're going to start a new cell. I think I'm going to take the same data frame from before, and actually I think I'm just going to copy these 3 rows in. And that way we can kind of print the data frame, we get this, and we can move forwards. Okay, cool stuff. So I think first we'll focus on getting the columns based on kind of slicing techniques. And although we can't use the same kind of slicing techniques using the colon syntax, just because we're using labels, or rather we're accessing columns based on labels and not their indexes, we can do kind of like a slice just by specifying which columns we want. For example, let's just actually create a label columns. For example, let's say I wanted just my first 2 columns. What I could do is I could say, let's say columns, let's just call this cols for short, is going to be equal to my data frame, and I just want to get a couple of columns. So here I'm going to open up my square brackets indicating that I'm accessing columns, but rather than entering the labels like this, okay, col1 and col2, I actually need to wrap these in another square bracket. Okay, that's because this initial square bracket, this will only take 1 positional argument. Okay, and that will just be the index. If we want multiple indices, we have to create a list of those indexes and then pass them in like that. Otherwise, we can absolutely fetch multiple columns this way. Okay, col 1 and 2, so we've basically just omitted column 3. Similarly, we can actually fetch the entire data frame's worth of columns but shuffled by doing something like this. Okay, let's say I wanted col 3, col 1, and then col 2. Okay, that absolutely works as well. That's going to basically fetch me my entire data frame just kind of rearranged. All right. Now, there's not a whole lot more we can do through with columns rather, so let's talk more about rows. Okay, so this is actually column slicing in particular, and this is more row slicing. Okay. Now we can actually apply a lot of the same slicing techniques using our lock and ilock functions as we did with regular series. Remember, as soon as we use the lock or the ilock function, it's as if we're fetching a series. So any kind of slicing techniques we do from there on out will be as if we're slicing just a regular series, because really we are. So let's say I want to get some rows, okay, And I'll start just by getting the first two rows, so row 1 and row 2. There's a few ways we can do that. We can do df.lock, and we can specify which rows we want by their index. So in this case, 0 and 1. Okay, I'm just going to go ahead and print out the rows there. Okay, let's see. Oh, actually, this should be ilock would be 0 and 1. Okay, you can see that it returns us our first two rows and our columns. Now, this is a whole data frame. It's not a series. Okay, and that's because there are still multiple columns worth of data that we're fetching. It's still two-dimensional data. Okay, similarly, if we did want to pass things in through the labels, we could do location, and then we could do the row labels. So in this case, row 1, row 2, etc. Okay, just like before, we can absolutely shuffle things around by specifying the order in which we want our rows to come in. So let's say I wanted, actually just going to comment that out really quickly. Let's say I wanted my rows to be completely shuffled. So I've got 4 rows. Maybe I'll do row 2, 3, 1, and then 0. Okay. If I want to print out rows, it's going to give me my whole data frame back, but again, things will be shuffled around. The columns remain exactly where they are because there's no reason for them to change, but the row order has changed. Similarly, I can do the exact same thing just by entering in all of my rows here in some order I want. So maybe we'll do row 2, row 4, like row 1 and row 3 or something. Okay, and again, that's going to give me a slightly differently ordered data frame. Now, for the rest of the slicing portion, I'm just going to be talking about the ilock function because we'll be applying some of those same Pandas, I guess this is not Pandas specific, this is Python slicing functionality using our colons. So that will take in numerical indices, and so that's why we're going to be using ilock from here on out. So we saw that we can get our first two rows like this just by specifying a list of the indexes we want. Similarly, if we wanted the first two, we could use the same slicing techniques from before. So let's say I want to say rows is equal to our df.ilock with up to 2. Basically, this is just going to get me row 0 and row 1, and then it stops at row 2. It doesn't include row 2. Okay, so again, exactly the same thing here, just by specifying or rather using this colon syntax. Okay. Now, similarly, we can specify a start and an end point. Let's say I wanted the middle 2 rows. I could do a start point of 1, end point of 3, and that's going to give me my second and my third rows here. Let's say I wanted my last 2. Well, if I know if I know how long it is, I can easily just say start at index 2 and end at index 4. But probably the better way would be to do something like rows df.ilock, and then we're going to do from -2 until the end, and that will give us the last 2 rows there. Okay, this is again just Python syntax, it's not Pandas specific. One other cool thing we can do, and actually this isn't data frame specific necessarily, I probably should have demonstrated this in the series portion as well, but there's no harm in learning it now, is if we want to skip elements, let's say for example I wanted only every other row, so row in this case it would be row 1 and row 3. What I could do is I could say rows equal to df.ilock, okay, and then I'm going to enter 2 colons and 2. So this basically, if we have 2 colons in our indexing brackets here, if we do a number on the last one, that will be kind of like the step count. So in this case, we're stepping by 2. We're fetching all the rows and all of the columns, but we're stepping by 2. Okay, so it should just return me row 1 and row 3. And indeed it does. Another thing we can do is, let's say we want columns, but we're trying to access it through ilock. What we need to do is we're going to say that we want all of the rows. Let's say we want every single row, but just a couple of specific columns. And actually, I guess this is actually a combination row and column slicing. So if I wanted all of my rows, okay, but I only wanted maybe a couple of my columns, so maybe I'll just do the first 2 columns. I specify that I want all of my rows by doing the colon like this with blank on either side, and then I'm specifying that I only want specific columns. So in this case, maybe up until 2. So I'm going to do colon up until 2, and that will say my first 2 columns. Okay, so now look at the results. I only get column 1 and 2, but I get all of my rows. Similarly, if I only wanted row 1 and row 2, I could do until 2 and then until 2, and that will give me just my first 2 rows and my first 2 columns. All right, so that is a bunch of different slicing techniques. You can definitely combine them in interesting ways to get the bits and pieces that you actually need from your rows. So this, I suppose, is actually, yeah, I guess this can be slicing rows and columns. So I'll label this as both. Also just wanted to quickly add in that previous point, just all of them and up until 2. Okay, good stuff. All right, so next we'll take a quick look at fetching items based on Boolean tests. Okay, so this will be booleans, and let's say that I want a specific column, or rather I want all the items from a specific column as long as they're greater than some value. So let's say I want all of my rows in column 1 that are greater than the value of 2. Okay, so in this case it's really only going to return me 1 and not a number, which doesn't really count. Or maybe let's say greater than 1, so this should return me 2 and 3. What I can do is I can say something like greater, you know what, let's just call this rows again, I suppose. And the rows is going to be the data frame selection. Okay, so I'm selecting columns this time. So I need to put my column selection right in here. And that selection is going to be everything from column 1, so col 1, that is greater than 1. Okay. So this is going to fetch me everything only in column 1 where the items are greater than 1, and it's just going to return me the results there. So if I go ahead and run that, then you can see that's actually, it's getting everything across the 3 columns, but only where it's greater than, only where the items in column 1 are greater than 1. So I think I actually worded that fairly poorly before. What I mean is that this will get all of the columns and all of the rows where the specific row in column 1, that element is greater than 1. So for example, you can see the results here. In row 1, the number in column 1 is not greater than 1. That returns false. So essentially we drop that row. In column 2, the value in column 1 is greater than 1. So we keep that whole row. Same with row 3, and then row 4, that returns false, so we drop that. Okay? So let's say I wanted all of the rows in my data frame where the value in column 2 is going to be less than 5. Well, that will return me row 3 and 4, because in column 2 I look and I see that, okay, that's less than 5, that's less than 5. These ones are greater than or equal to 5, so we'll keep those. And the way in which we do that is we'd say rows equal to df, and we want df.col2 is what we're looking at now, and we want the values that are greater than or equal to 5. Okay, so if we go ahead and run that, we should get row 3 and 4. That's to be expected, okay, because the other 2 fail. Now, keep in mind that this is going to return all of the columns where this applies, okay? So if we want to select specific columns from there, then we would have to go further into this and select only those columns, okay? Unfortunately, we can't apply the same logic to row selection. For example, I can't substitute out the column selection here with the df.lock or df.ilock. For some reason, Pandas doesn't really like that too much. Okay, the last thing that I wanted to show you here is actually a couple of really cool functions that help us to retrieve the first n or the last n rows of a data frame. And these are our head and tail methods. So let's say first/last n rows. So we use the .head method to, by default, return us either the first 5 rows, or if we want a specific number, then we can put in a number as a parameter. So let's say first n is going to be equal to, let's just say n rows actually, is going to be equal to our df.head, okay, and we can go ahead and just print out n rows. Okay, this is going to return us the first 5 rows. Now in our case we only have 4 rows, so it's going to return everything. Let's say we only wanted the first 2 rows. Do head of 2, and that's only going to return us the first 2 rows there. Similarly, if we want the last rows, we could say n rows is equal to df.tail of 2. Okay, and that will give us just the last 2 rows, row 3 and 4. Similarly, if we enter nothing, then that's going to give us the last 5 by default. So I'm actually going to say last 5 by default. Okay, otherwise that's pretty much all we want to cover here. We went over quite a lot. We specifically focused on column and row slicing using a combination of column selection, ilock, and lock. We learned how to slice both rows and columns simultaneously, how to get items based on Boolean tests performed only on columns, And then also how to get the first and last n elements using head or tail. So this is definitely something I'd recommend you practice, especially when getting row and column selection. It's important that you know these slicing techniques moving forwards so that you can fetch the bits and pieces of data frames that you want, because very often you'll read a whole data frame and you're not going to want all of that data. Okay, so definitely play around with that. When you're ready to move on, we'll go to the next topic, which will be more getting properties of data frames. So stay tuned for that. Thanks for watching, and see you guys in the next one.